Good morning guys, and welcome to today's video on solving simultaneous equations graphically. Okay, right guys, this video was recorded on Monday the 17th of August 2020. Right guys, if you're new, welcome to my channel. My name is Abdallah Wahishi and I make maths videos for Key Stage 1, Key Stage 2, Key Stage 3, GCSE and A-level maths and further maths, as well as undergraduate level degree maths. Okay, please do subscribe to my channel if you're new, and drop the video a like and turn on post notifications so you guys can be notified of when my videos are. Okay, but let's get in today's video. Right guys, in today's video we're going to look at how to solve simultaneous equations graphically. Okay, so this is all to do with obviously plotting graphs here and using like tables of values to be able to actually find solutions to our equations. Okay, so we're looking at grade 3 and 4 for GCSE level maths here, grade 4, 5 for the GCSE curriculum 9 to 1. Okay, right guys, so we're gonna go through two examples for like today's lesson. So example 1, so we're asked to solve graphically 2x plus 2y is equal to 8 and then x plus 2y is equal to 6. Now we can see here that is like a simultaneous equations. Okay, obviously that can be solved obviously algebraically, but we're gonna look at how to actually solve this actually graphically in like today's lesson. Okay, so what I did was, first of all guys, was I rearranged both of them actually to make it in the form y is equal to mx plus c, where m is the gradient and c is my y-intercept. Okay, so I rearranged x plus 2y is equal to 6 in the form of y is equal to mx plus c. So what I did was I subtracted x on both sides and then I divided by 2 for x plus 2y is equal to 6 to give me y is equal to 6 minus x over 2, which simplifies to 6 over 2, which is 3, minus x over 2, which is minus half x. Or I can write it as y is equal to minus a half x plus 3. Okay, so that is my first equation. Okay, so that's that one there. And then my second one, okay, 2x plus 2y is equal to 8. Okay, I've made a mistake here. For some reason, I've put 6 here and not 8, sorry. Okay, so the answer, okay, so rearranging it, I should get y is equal to 4 minus x, not 3 minus x, sorry. So when I rearrange it, I minus 2x on both sides and then divide 3 by 2. Okay, but for some reason, I've put a 6 here and not an 8. So it should be 6 over 2, which is 4, not 3, sorry. So it should be 4 minus x. So y is equal to 4 minus x. Okay, so my equation would be y is equal to minus x plus 4, which obviously actually changes my answer now, but we will come on to that in a second. Okay, I would then, so what I then did actually was I then plotted a table of values, okay, for my equations. So that's x plus 2y is equal to 6, and then that one's 2x plus 2y is equal to 8, okay. And then I plotted my graph here. So then I plotted my graph here on that. Okay. So y is equal to minus half x plus 3. Yeah. So a negative gradient obviously will look like that. Okay. And then it goes to positive 3. So that's going to be that one there. Okay. And then the second equation is y is equal to 4 minus x. So so it should go through 0, 4 and not 0, 3, sorry. Okay, for that equation there. Okay, and then it should intersect at 2, 2. And the reason I know that is because on my table of values, I can see here that when x equals 2, y is equal to 2 for both equations. So y is equal to 2 for both equations, which means that is the point at where those two lines meet, i.e. where those two lines intersect. Okay, so that is how I know that is my intersection. Okay, so my intersection is going to be 2, 2, not 0, 3. Okay, so like ignore that actually. Yeah, the intersection should it should just cross at one point, and that's 2, 2, and not 0, 3 actually. So yeah, I made a mistake there, guys. Apologies. Okay. So that is how I would do that actually. So that I can see from here, from when I subbed in my table of values, that I got that as my answer. Okay, so that is how I would do that Okay, yeah, that is actually, yeah, example one for, yeah, how to solve simultaneous equations, yeah, obviously graphically. So what you would do is, obviously, if it's in the form of y equals mx plus c, then you would just plot a table of values, okay, usually, yeah, obviously from -2 to 2 actually, or -4 to 4, depending on, yeah, depending on obviously what they actually give you in the exam, but usually they will tell you, yeah, what your interval is actually, yeah, on the actual exam paper. Okay, so I hope that actually made sense, guys. So yeah, apologies, actually, yeah, apologies about the mistake there. So it should be 0,4 for that one and not 0,3. So it just intersects at 2, 2. Okay, right, guys. Example 2. So it says y is equal to. So we got here y is equal to x squared minus 2x and 2x minus y is equal to 7. Okay, so what I did was I plotted the graph. So I did a table of values. Okay, so -1, 2, minus 2, 1, -1, 0, 1, 2, 3. And then I plotted my values for y is equal to 2x minus 7 and y is equal to x squared minus 2x. And this is what the graph I got actually as my answer. So this is my answer for this, okay? So y equals x squared minus 2 actually looks like that. And y equals 2x minus 7 looks like that actually. So it goes through 0, -7, and it goes through there, okay? So that is how I would do that actually. And then obviously this one was a bit more trickier. This one I had to actually solve it graphically to actually find out what my solutions were, okay, for this one. Okay, but I got, yeah, so I believe I got, so the x solutions were 2 minus root 3 and 2 plus root 3, and then my y solutions were 4 minus 2 root 3 minus 7, or 4 plus 2 root 3 minus 7. Okay, so they were my intersections for those graphs. Okay, so that one was a bit more trickier. Okay, but yeah, but obviously, yeah, what you do actually, yeah, is plot your graphs. Okay, so yeah, so you plot that. Okay, so yeah, I was sort of actually that 2x minus y equals 7, so that was rearranged to the equation y equals 2x minus 7. So that's got a gradient of 2 and an a y-intercept at -7. Okay, gradient of 2 means that, yeah, it's a positive 2, so it looks like that. Okay. So yeah, so that's my answer. And then for the quadratic, I got that because when I factorize x squared minus 2x, I get y is equal to x brackets x minus 2. Okay, so my solutions are x equals 0 and x equals 2. So it goes to 0, 0 and 2, 0. Okay, and that is how I got my answer, guys. Okay, so I hope it made sense, guys. Yeah, any questions or queries here, obviously feel free to put it in the comment section. But yeah, but to summarize, what you would do is you would obviously plot your table of values. Okay, so yeah, from from the appropriate intervals, okay, from -2 to 2 or -4 to 4 or -5 to 5. Okay, you would then obviously then once you obviously worked out your y coordinates, you would then obviously plot that on the graph. Okay, so you would plot both, yeah, obviously both both curves, yeah, or line on the same graphs. Okay, yeah, on the same set of axes. Okay, and then obviously where they intersect, that is where I have what we call a graphical solution to my equations. Okay, so this one, yeah, so this one actually crosses at 2 points because I have a quadratic and a linear. Okay, so yeah, it crosses that actually. Yeah, and then obviously in the exam actually, yeah, you will obviously be given actually lined paper, so it will be a bit more accurate. Okay, but yeah, but I hope it actually made sense, guys. Yeah, and yeah, I'll do like another video on this tomorrow, and then I'll move on to solving inequalities graphically. Yeah, later on this week, yeah, or maybe tomorrow's lesson as well. Okay, so I hope it made sense, guys. Yeah, please like, comment, share, subscribe. Yeah. Yeah, and and feel free to obviously share my videos around actually, yeah, if you've got any questions or queries. Okay, yeah, and yeah, any questions or queries, yeah, put it in the comment section. Okay, and I hope you're all well, yeah, and I hope you all stay safe. Okay, so I will see you hopefully tomorrow. Okay, happy Monday. Bye now.